Number 5, half-life. The mass in grams of a sample of radioactive material decays according to this equation, where X is time in years. How many grams of the material are present originally? So there's 2 ways you can know this answer. Anybody have any guesses? So if we think back to exponents, what's the original form for exponential function? Correct. A times b to the x. And what was a? A is the starting value. So that's one way we can know it, right? That's one way we can know it's 1,000. But what should I put instead of just 1,000? Yeah, it's asking specifically for grams, so we want to make sure to put spell it right, a label on our answer, right? What's another way you could have figured that out? What's our time when we're saying how many grams of the material are present originally? The time would be 0, right? What's anything to the 0 power? It's itself or 1? 1, right? Anything times 1 is itself, but anything to the 0 power is 1, right? So if this is 1, what's 1 times 1,000? Oh, look, 1,000. Okay? That's fine. Do it. So what about B? Find the half-life of the substance, or the amount of time it takes for for half of its mass to decay. So what are we doing here? If it started at 1,000, what's its half-life? Or sorry, how much will it have at its half-life? 500, right? So where should that go? M of x, right? So 500 equals 1,000 times 0.983 to the x power. So how do we go about solving this one? So before we can put it in logarithmic form, we have to isolate the base. Exactly, we have to divide, right? So what are we dividing by? So we're going to divide both sides by 1,000. Guys, why don't we multiply these two together? Yeah, that's frowned upon, right? That's so sad. Exponent police will come and get you. Remember that? Okay. Only the 0.983 is being raised to the power, and we have to take care of powers before we take care of multiplication. Okay. So we're going to get rid of the 1,000. So that leaves 500 over 1,000, which is what? So here's a good question for you then. Okay. You said 1/2. Is it okay to go to the decimal here? Why is it okay to go to the decimal here? It's a nice decimal. Okay, it's something that doesn't have to be rounded for us to write it down. So do you want to go with the decimal, or do you want to go with 1/2? Decimal, okay. Does it matter? No. 0.983 to the x. Now what would you like to do? Now is the time for a logarithmic form, right? Once the base is isolated, now is the time for logarithmic form. So how about if we do log base 0.983, excellent, of 0.5 equals x. Super easy at this point? I'm not trying to say that disrespectfully, because if you don't know what to do, it's not super easy, is it? Okay? But those of you who think it's super easy, what are you doing? You're literally just putting it in the calculator, right? Okay? So let's put in, oops, you can't see that. Log, not that. Log, thank you, 0.983 of 0.5. So what are we going to write as our answer? So x equals 40.426, it would be, right, if we rounded it. But that answers the equation, right? And if we want to get really technical, it's just approximately because we did round, right? Now let's answer the question. Find the half-life of this substance. What are we going to write as our answer? Does it make any sense for me to say 40.426 years? What does it make sense? About 40.4 years? Right? Because while I know 40.5 years, that would be 40 years and 6 months. So I know 40.4 would be a little bit less than 4 years and 6 months, right? I don't need to go and find out exactly how much that is unless it asks me, but it doesn't. It just says find the half-life. And I think that saying 40.4 years is just about fine. You guys okay with that? Are there any questions?